Have you ever wished you could just duplicate something you own? What if I told you that, mathematically, it's possible to take a solid ball, cut it into a finite number of pieces, and then reassemble those pieces to create two identical copies of the original ball? No stretching, no bending, just cutting and moving. This isn't a magic trick. It's one of the most baffling and mind-bending results in all of mathematics. The Banach-Tarski paradox. It sounds completely impossible, right? Our everyday intuition screams that volume must be conserved. If you cut a cake into 5 pieces, you can't reassemble them to make 2 full cakes. And for all practical purposes, you're correct. But in the strange, abstract world of pure mathematics, the rules are different. So, how can this be? The secret lies in the nature of the pieces. These aren't the kind of pieces you could create with a knife. They are infinitely complex, unvisualizable, fractal-like sets of points. Imagine trying to describe a cloud nut, just its shape, but the exact position of every single water molecule. The pieces in the Banach-Tarski paradox are even more intricate than that. They are so jagged and scattered that they don't have a well-defined volume in the way a normal, physical object does. Think of them as collections of dust, spread so thinly and weirdly that the concept of how much space they take up becomes meaningless. To even define these bizarre pieces, mathematicians had to rely on a powerful and controversial tool called the axiom of choice. This axiom is a fundamental principle in set theory. It essentially states that if you have a collection of baskets, each with at least one object inside, you can create a new set by choosing exactly one object from each basket. It sounds obvious, almost trivial. But when you apply it to an infinite number of baskets, it leads to some truly wild consequences, like the existence of these non-measurable sets that make the paradox possible. The paradox works by exploiting the infinite nature of the points within the sphere. The pieces are constructed in such a clever way that when you rotate and move them, the points that were missing from one sphere are perfectly filled in by the points from the other pieces, creating 2 complete solid spheres, where there was once only one. It is like having an infinite library and rearranging the books to create 2 identical copies of the entire library. The paradox doesn't create matter out of nowhere. It resorts an existing infinity of points into 2 new infinities. So, what does this all mean for the real world? Can you really turn your 1 gold bar into 2? Unfortunately, no. The paradox is a purely mathematical statement. The pieces are theoretical constructs, so mind-bogglingly complex that they can't exist in physical reality. No knife could ever cut them, and no machine could ever reassemble them. But the philosophical implications are staggering. The Banach-Tarski paradox forces us to confront the limits of our intuition. It shows us that the mathematical universe is far stranger and more mysterious than the physical world we experience. It reveals a deep chasm between the abstract concepts of points and sets and the tangible objects we see and touch. It's a beautiful reminder that mathematics isn't just about counting and measuring. It's about exploring the very boundaries of logic and possibility, even when it leads to results that seem to defy reality itself. The world of math is full of such wonders, challenging what we think we know. Thanks for joining me on this journey into the impossible. If you enjoyed having your mind bent, don't forget to like and subscribe for more explorations into the mysteries of science and mathematics. See you next time.